Okay, this is lesson 12 from second semester where we're going to solve equations using logarithms. And over here we have a lot of our important log rules. When we take the log of both sides, we're going to use the natural log, this ln, which is the log with a base of e. And then when we're working, if we get to take the natural log of e, we need to remember the natural log of e is 1. Okay. So we'll do the I do. For the first one, solve the following equation. This one's really easy. This says the natural log of 4x minus 7 equals the natural log of x plus 5. Those are with a base of e. The base of the natural log is a base of e. In this case, we don't need to use that information because if these logs are the same, that means their arguments must be the same. So we can set their arguments equal to each other. And then use inverse operations to solve for x. So we can add 7 to both sides and get that 4x equals x plus 12. That was add 7 to both sides. Sorry about the bad handwriting. And then we'll subtract x from both sides to get 3x equals 12. Divide both sides by, 3. I'm very tired. And get that x equals 4 for this first question on the I do. So again, we set the arguments equal to each other because the logs say that they're equal to each other. So I'm going to erase that to make room for the next problem. All right, so now we're doing this problem. Solve the following equation. The log base 2 of 5x minus 17 equals 3. So the first step is going to be to think of this logarithm thing as exponential. So I like to draw arrows to help me write the exponential form. So I'm trying to get this into something to some power equals something. That's what I'm going for. So with the arrows, start with the 2 over to the 3. So that 2 is the base. 2 to the third power equals all of this, 5x minus 17. So that's exponential right there. So we just did rewrite as exponential. Next is we need to simplify that exponent. So 2 to the third power is 2 times 2 times 2. So that's 8. So 5x minus 17 equals 8. Finally, let's solve using inverse operations to isolate x. So here 5x minus 17, so add 17 to both sides and get that 5x equals 25, then divide both sides by 5 so that x equals 5. So again, we had it as logarithmic, log base 2 of this thing. Rewrite it as exponential. Then 2 to the third power is something that we all understand. Simplify the exponent and then solve. Okay, last part of the I do, and the most important one, is solving for unknown exponents. You can see that x is an exponent here, and that's what we need to solve for. And we can solve for that exponent by using logarithms. So first, we need to isolate the base and exponent, meaning to get to this x, we need to get to this, so we have to get to this. Right now, we have 2 multiplied by 15 raised to the exponent. So let's divide both sides by 2. And that's canceled. We're left with 15 to the 3x plus 1 power equals 570 divided by 2 is 285. Okay, so we isolated the part that has the exponent we're trying to find in it. All right, so the next thing we do is take the log of both sides to bring down the exponent. And here's what I mean. If we have something like, let's see, the log of 10 to the second power, this equals the same as 2 times the log of 10. So when we take the log of something with an exponent, what we can do is bring that exponent down in front as a coefficient. So now let's do that. So we're going to take the log, we're actually going to take the natural log of both sides. And when we do that, we'll just show the whole thing. The natural log of 15 to the 3x plus 1, close that, is equal to the natural log of 285. And we know that's true simply because we're allowed to take the log of both sides. And if we were equal before, we are still equal now. Okay, so now let's show the exponent coming down. So when we take the log of something with an exponent, we can take that exponent and write it in front as a coefficient. So 3x plus 1 in parentheses times the log of 15, the natural log of 15 in this case, equals the natural log of 285. So here we took the log of all of this, and that brought the exponent down in front. So now we need to isolate x, isolate the 3x plus 1. So right now, 3x plus 1 is multiplied by the log of 15. So we need to divide both sides by the log of 15, the natural log. Now from there, we have 3x plus 1 equals this weird number. Okay, so you divided both sides by the natural log of 15. And to make this more digestible, I use the calculator to simplify what is the natural log of 285 divided by the natural log of 15. So do that and get this decimal approximately 2.087. Now from there, we're almost done. We do need to isolate this x with 2 more steps. It's 3x plus 1. So we'll subtract 1 from both sides. So then this is 3x over here and over here. So 2.087 minus 1 is 1.087. Then this is 3 times x, so we need to divide both sides by 3. So when we divide, this is an approximation, so we give it a squiggle. X equals approximately 0.362. So I know that was a lot. Again, we had 2 times 15 to the exponent equals 570. We have an unknown exponent. So to solve for that, we need to isolate it, get it by itself, divided both sides by 2. And then we have 15 to an unknown exponent. We can get the exponent down by taking the log of both sides. The natural log is what we did. The log of this brings down the 3x plus 1 in front, multiplied by the natural log of 15. And then we had to isolate this, so we had to divide both sides by the natural log of 15. We simplified this as a decimal, and then we solved for x. Subtract 1 from both sides, divide by 3, and that gave us our value for x.